Another kind of factoring you might see once in a while is this difference or sum of perfect cubes. So perfect cubes is not something you're probably like totally familiar with. I'll just give you some quick examples. This number here, 64, that's a perfect cube because it's 4 times 4 times 4. If a number multiplies by itself 3 times, whatever number it lands on, that's a perfect cube. So 27 over here, that's a perfect cube because that's what you get if you multiply 3 by itself 3 times. So just like we have perfect squares that, like, for example, 25 is a perfect square because it's 5 times 5, or like 49 is a perfect square because it's 7 times 7. A perfect square is the number you land on when you multiply a number by itself 2 times. If it's a number that you land on when you do it 3 times, that's called the cube. So you're going to want to be on the lookout for those types of numbers, but I'll just be honest, most people don't have those memorized. So the thing is, it's a problem like this. Basically, if you see like a variable to the third power, and then everything else is basically just a constant with no other b's or anything like that, that kind of tells you that, okay, I better start thinking about numbers that multiply by themselves 3 times to give me this, and 3 times to give me that. The second thing about factoring these things is there's just this formula to kind of memorize. These are the two formulas. And it might seem kind of silly that I have you memorize these in this day and age, but I do want you guys just to kind of look at the patterns between the two things and think about how these two things are the same and how they're different. So here's how they're the same. They both have a cubed, they both have b cubed, and they both go a, b, a squared, ab, and b squared. That's how they're the same, right? Every part of it is the same. So how are they different? How they're different is where these signs come into play. And actually, there's this cute little thing you could do to memorize the way the signs go. It's this thing called soap. Let me quickly draw a picture of soap so you could have this ingrained in your memory. People used to use bars of these things called soap to wash their hands. Now it's all liquid. There used to be a bar. I'm going to put some bubbles on here too so you know what I'm talking about. That's a bubble, bubble, bubble. That's some soap. Why am I drawing soap? Because the deal with the signs is the signs are the same, then they're the opposite, then it's always positive. Now let me explain what that means. It's a little cryptic. Where's my pointers? If it's minus, this sign is the same as this. Whatever this sign is, this side is the same. This sign is the opposite. This sign is positive. If this is the sign, this sign is the same. This sign is the opposite. This is always positive. So that's the deal. Whatever the signs are, it's always the same sign, the opposite sign, always positive. And that's just a way to kind of help you memorize it. Now I'll show you how to use it in the next few examples.